Welcome, class, to lesson 8-9, day number 2. Today, strong mathematicians can decompose quadrilaterals and triangles into other figures. So please take out your notebook, your pencil, write down today's date, the name of the lesson, and let's begin. So we have some good review notes. So you have to write these down because you probably have these over and over. You're like, Mr. Kamen, we know already, but the more we hear them, the more they get stuck and the more math vocabulary we start to increase. So we have an acute angle, 0 to 90, right angle, 90 to 180. A right angle is exactly 90 and a straight angle is exactly 180. Triangles, a right triangle has one right angle, an obtuse triangle has one obtuse angle, and an acute triangle has three acute angles. And if we divide triangles by their sides, an equilateral triangle has three equal sides, an isosceles triangle has two equal sides, and a scalene triangle has 0 equal sides. And we talked about the notes of different shapes of what a quadrilateral is, a parallelogram, rhombus, square, rectangle, and trapezoid, and the traits that make them such. And yesterday we talked about the diagonal of a quadrilateral. We're going from opposite sides, opposite vertices to make different triangle shapes. We know that right here is one of them, and the other way would be that one, and it creates different type of triangles, which we learned about yesterday. And with that, just some more practice today. List the names for this quadrilateral. One thing about that, first thing that pops in my head is a parallelogram. And then I can kind of go further down the list. Is it a rhombus? No, the sides aren't equal. Is it a rectangle? Nope, there are no right angles, so it can't be any further than a good old-fashioned parallelogram. So what we're going to do is we're going to divide this in half one way. We're going to go from where C is and where B is, and put those lines right there. So we have triangle CAB and triangle CDB. And we know if we look at these right now, what type of angles they are. If we look at this angle of that opposite of the line that we drew, those both look like, here's my 90, they're past 90, so they both would be obtuse triangles. And the other one would also be an obtuse triangle. Does that mean the other ones are going to be obtuse? Well, maybe if you remember what yesterday's lesson was, that might help you out. And our next one right here, we're going to cut it from this way to go the other direction. Now we have triangle ACD, not ACDC, and triangle ABD. Now if you look at those angles look really small. Like this would be where 90 is right here and right there, so they're not quite 90, so that would tell me these are both acute triangles. So hopefully when you've been doing this right now, something might be like, hey, wait a second, I'm starting to realize that if I have an obtuse on one way, it seems like I always have an acute the other way. And it seems like if I have an acute one way, I have an obtuse the other way. So maybe that holds true for a lot of these shapes. We'll find out. And right now, as we did yesterday, we're trying to figure out what triangle could be used twice to form this quadrilateral. What kind of triangle is it? So if you kind of look at this shape right now, well, the one thing that really sticks out to me is I see this right here, and I see right angle right there, which the only one that I see a right angle with is V. So think about this triangle right now. It looks like it's obviously a right triangle by the angle. And it looks like this side is smaller than this side, and this side looks even longer, called the hypotenuse. So it would be a right scalene triangle. And what shape did it make? Well, it made the shape that pops out right away to me, I said right away, was a rectangle. But we know that a rectangle can also be a parallelogram because it has four sides and two opposite sides that are parallel. And that looks like the names of that shape for that quadrilateral. So there's some good practice to think about which one it looks like. I'm looking for clues in shapes to help us to figure out how can we break shapes apart. And now it says a vertex is a point shared by two sides of a polygon. Triangles are examples of polygons. Look at this isosceles triangle. So remember what isosceles means. That means there's two equal sides for J, K, and L for the following question. So right now I should draw this triangle out, an isosceles triangle. Label it J, K, and L, so we can figure out what, and answer some of these questions that go with it. It says draw a segment from the vertex between the equal sides of the triangle. All right, so to draw a segment, so we have that. We'll go right here to my segment. We're going to go to the equal side, so we're good to go with our segment. Equal sides, well, we know that this side looks equal right here. Well, we'll get back to this one. This side looks equal and this side looks equal. So we're going to draw it between those two, and we go right down to the other side so it's perpendicular to the other side. So right through here and straight down so it is perpendicular. And label the segment and mark the right angles. So we'll give this a letter. We have to label it right now. So we'll give this the letter M. And it looks like this forms perpendicular, means it formed right angles. So we just took our triangle, we cut it in half, we formed two triangles that have right angles. So it says, name the segment formed by the perpendicular segment of triangle JKL. So it looks like these are the new segments. It looks like L to M is a new segment, and M to K is a new segment. So we know that we got LM is our new segment, and we got KM or MK is our new segment. And the question is, what is true about the lengths of the segments? Well, if we cut it directly in half from something that's to equal itself, that means those are actually look like they're equal to each other, and those sides would be the same. Now we have to name the triangles formed, and are they the same size and shape? Well, let's name the triangles formed. So we have a new triangle right now. We have triangle JML and triangle, I'm going to slide down a little bit, triangle JMK. And if I look at both of these, well, since I have these new right angles right here and right here, these would be both right triangles. And as I look, are they the same size and shape? Well, that looks like they are pretty, if they got some of the same size, well, this line's the same and this line. And we just realized that this line's the same and this line's the same. And if they share this is the same line, well, then this has to be the same. So my guess is, are they the same? That would be a big old, yes, they are. So you can draw down that drawing of our JKL, how we broke it apart with using a straight line to the opposite to create perpendicular lines, and all the questions that go with that. And now it's your turn today. So you draw a big line across the sheet, box 3. Now your turn. So once again, I want you to list all the names for the quadrilateral, cut them in 2 different ways, and label all of the triangles and what type of triangles they are. So you can pause the video right here and solve this problem. And we can look at this problem right here. It looks very similar to the one you had yesterday, but maybe there's a slight difference you're noticing from the other day. So you can figure out what triangle made that one, identify that triangle, and then list all the names of the quadrilateral that it made. And now you have your triangle. It's a little different than my triangle, but we're going to do some of the same type of things of taking a triangle and cutting it and making perpendicular opposite sides and label them. So good luck. So make sure you read all the questions to help you out. It says a vertex is a point shared by 2 sides of a polygon. Triangles are examples of polygons. Look at the scalene triangle, triangle PAC. What is true about the sides of your triangle? Draw a segment from one vertex so that it is perpendicular to the opposite side. Label the segments and mark the right angles. Name the triangles formed. What kind of triangles are they? And are they the same size and shape? We know what happens with an isosceles triangle, but what happens with a scalene triangle? And that's what you're going to figure out in your work today. Also, if you have any questions, comments, or concerns, feel free to write them down or share them out. Also, if you have any strategies that you use to help you, make sure you include those as well. And as always, thanks again for another great lesson.